Okay, so we're on 4.7. We're dealing with the coordinate proof. And it's just a type of proof that involves placing geometric figures on a coordinate plane. Nothing very hard, other than you're given a coordinate plane, and you're going to take a figure, and you're going to place it somewhere on there. All right, so if I have a right triangle, does everybody know what a right triangle looks like?
Yeah.
All right, and what are the legs of a right triangle touch the 90-degree angle, right?
Yeah.
So one of the legs is 7.5, another one is 4. And it doesn't matter which one you use, but realign this. Okay, so we're going to go line it up. Here's going to be my vertex with my right angle. And I'm going to go up 1, 2, 3, 4 places and over 7.5. Now this is 7, and I need to go just a halfway over. And I've got 7.5. And then I'm going to connect the two ends, or the two legs together to make my right triangle. But it says label the vertices, so if I put it on the y-axis and the x-axis, this vertex would be at 0, 0. This one would be at 7.50. And this one would be where? 4, 0. Very good. All right, so there's my vertices, and I want to find the length of the hypotenuse. Well, the hypotenuse is always the angle the side directly opposite of the 90-degree angle. Does anybody know how to find the distance from 4, 0 to 7.5, 0? No, because in your graphs, you always write your x value first, and your x value goes from left to right. So we went 7.5 to the right, and I went up 0, so that's 0. Okay, so how do you find the distance from 4, 0 to 7.5, 0? Okay, you could normally count how many you moved up or down only if it's a straight line. Straight line, horizontal, or vertically. Is this a straight line horizontally or vertically? It's slanted. So you can't do that. What else can you do? I want to find the distance between those 2 points. I'm sorry? Okay, if you count how many squares the line goes through, it won't work because it's a slanted line. Rise or run is slope, and that is not the distance. Distance formula. And the distance formula is this. D equals the square root, or the distance equals the square root of your x numbers subtracted from each other. And then you square that answer, and it's always going to be positive, plus the y values subtracted from each other. And then you're going to square that answer. Okay, now you notice my x values have subscripts, so do my y values. All it means is that x2 and y2 come from the same ordered pair. x1 and y1 come from the same ordered pair. All right, it does not matter which ones you give where. All right, so like 4, 0 is an ordered pair. And another one is 7.5 and 0. All right, so my x values are 4 and 7.5. So if I choose 4 to be my x2 minus the 7.5, okay, and I'm adding it to my y values. Now, if I chose 4 for my x of 2, that means my y2 has to be what number? 0. Excuse me, that's backwards. This one's backwards. This is supposed to be what?
4, 0.
No, it's not 4, 0. That's where I listened to somebody else. You moved 0 places on your x-axis, but you moved up 4. So it should be actually 0, 4. Make sure you get that corrected, and we'll start over from here. Okay, 0 places you moved on your x-axis, but you went up 4. That's where the 0, 4 comes from, not 4, 0. All right, so then we substituted into the formula. X of 2, you can make it the 0 or the 7.5, minus my x of 1, plus my y2, which would be the 4, minus my y1, which is 0. All right, so you're squaring that second ordered pair, excuse me, not ordered pair, the second quantity, and you simplify following an order of operations. So order of operations is parentheses, right? Do we have parentheses? Yes, so 0 minus 7.5 is a negative 7.5. If you don't square it with the parentheses, it will give you the wrong answer. Okay, it's going to be a positive number. And 4 minus 0 is 4, and you square it. So 7.5 squared is 56.25. And 4 squared is 16. And you add those together. And you get 72.25, and you take the square root of that number, and you get 8.5. And we don't have a unit of measure, but we're just going to call it units. So we said that's 8.5 units. And what I want to do is go back and look at the picture and show you that there's no way you could have looked at it and found the hypotenuse and discovered that it's 8.5. All right, look. There's no straight line through it. You went through 1, 2, 3, 4, 5, 6, 7. Part of 8 boxes, but not a full 8, so there's no way that you could have guessed 8.5 units as the distance. Okay. You had to use the distance formula. And a good thing to know, anytime you're finding the distance of anything, the length of an object, and you're given on the coordinate plane, you could always use the distance formula. Even if you're not given on the coordinate plane, and you can set it as the origin, you can kind of figure it out if you know the length and the width. Question? Mm-hmm. Yes. I'm going to show you one more, but yes, the distance formula is the one that we'll be using. This is all online, so you can just click on it and download it. You won't have to copy everything down. And it's in your book also. All right, so in example 2, place the figure in the coordinate plane, label the vertices, and give the coordinates of each vertex. All right, I have a rectangle. What do we know about rectangles?
4 sides.
They have 4 sides.
2 sides are currently the other 2 sides.
So 2 opposite sides are congruent, and the other 2 opposite sides are congruent. All right, so we have a rectangle. It's a 4 by 6, and one of the vertices is at 0, 0. All right, so I have to start at 0, 0. All right, then I have a 4 by 6 unit. Well, do I go up by 4 or up by 6? It does not matter. But yes, she said up by 4, so we go up by 4. 1, 2, 3, 4. Make sure you label your graphs and make your point. So this is 0, 4. Everybody okay with that? Then we move over how many? We've done 4, 6. 1, 2, 3, 4, 5, 6. All right, I'm going to show you how to find that point without counting in a second. Well, we know that this one has to be 6 also, right underneath it. We move 6 places for our x-axis, 0 for our y. Here we move 6 places from our x-axis. How many did we already move for our y? 4. Easily found your information. You want to connect it to make a rectangle, and you're done. that too bad? All right, again, if you want to find the links between certain points, you've got to use the distance formula. Okay, place the figure in a coordinate plane, label the vertices, and give the coordinates of each vertex. Explain the advantages of your placement. Hey guys, where would it be easiest to make our figure?
0, 0.
Why? Why is it easier to start at 0, 0? I want to offer that. Why is it easier to start at 0, 0? She's right. Why? Okay, so it's at the starting point of the y and the x. Anybody else think of anything else to add to that? All right, so we start at y, the zeros for the y and the x. And the reason that I choose 0, 0 is because I can easily find the units. If I go 3 units up, I've got the next vertex. And if I go 8 units over, I've easily got my coordinates for that one also. So there's your point. And our advantages would be what? Why did we choose that?
Because you consider units easier.
Very good. So she said you can find your units easily. They'll start at 0, 0, and that means that you can find your coordinates fairly easy by using those units. So the easiest thing to do is to start at 0, 0, or around the x and y origin. Okay, or the origin of the graph, the x and y axis. An example 4 in the diagram, triangle ABC is an isosceles triangle. What do we know about isosceles?
No, 2 sides equal.
Good. 2 sides are equal. What else do we know?
Equals 180.
Okay, all 3 angles in a triangle add up to be 180.
Both triangles have a right angle.
Okay, not an isosceles, but we do know that the base angles are congruent, right? That's what we know about an isosceles. All right, it says the base is 20 units. So this whole base is 20 units. All right, and the height is 10 units. Okay? How do I find the length of B to C?
Well, you already know that C is 10 units. So A and C are both 10 units.
Okay, so what do you mean by A and C are both 2 units? What's C? What's the coordinate for C? 10 what? How'd you get 10, 0? Did you count? No. Here's the deal. This was 10 units away, right?
Yeah.
Because it's an isosceles triangle, if you cut straight down the center, it's going to make 2 congruent right triangles.
Just do 20 divided by 2.
20 divided by 2 is 10. It's both positive on the positive side of the coordinate, so it's 10, 0. Very good. What's B? 0, 10. 0 on the x-axis, but up 10 units. Very good. So when I label my coordinates, B is the point that I'm looking at, and I'm going to label it 0, 10. Okay, that is a coordinate. All right, the next one is C, and it is located at 10, 0. You've got to write it like that in order for it to be completely correct. How do I find the length of a leg? What's a leg?
The thing.
What thing? Okay, one of the congruent sides.
It's the one that's in between both of them. And
So
bottom,
this one right here?
yes, and bottom.
That is not the leg. That's the leg of a right triangle. What is the leg of triangle ABC?
That's what I thought you said.
If it was a right triangle, if you treated it as AB, whatever this letter is down here, that would be a right triangle. But I'm looking at the big isosceles triangle. BC is a leg. What's another leg? Okay, AB. Either one of those you can find the length of because they're going to be the same, right?
Yeah.
Because they're legs of an isosceles triangle.
Yeah.
Which one would you like to find the length of? Okay, BC is probably easier because you have no negative numbers, right?
Yeah.
And how do you find the length on a coordinate plane? Distance formula. Does anybody remember what the distance formula is?
2 minus
Parentheses, x2 minus x1.
Squared
Close it and square it.
plus parentheses y sub 2 minus y sub 1 parentheses close squared.
Very good. All right. Does it matter what points? Well, we said we're going to use BC, and one of them is located at 0, 10, and the other one's located at 10, 0, right?
Yeah.
All right. So how do I substitute that in?
Well,
Okay. So x of 2 is going to. You're saying that this one's that. Okay. So you're saying 10
and then
minus 0.
close
Okay.
plus
Plus
10 minus 0.
0
0
minus
minus 10.
close.
Parentheses close. 10 squared.
Then you
All right, so what's 10 squared?
can
10 squared is 100.
12
And what's negative 10 squared?
Negative 100.
Okay, it can't be a negative 100 because negative 10 times a negative 10 is a positive 10 squared, which is 100. All right, what's 100 plus 100? 200. You're multiplying. We're adding. All right, and it says to round to the nearest hundredth. Okay? So hundredth is 2 decimal places. Did y'all know that? Good. So hundredth is 2 decimal places. So I get approximately this because my calculator rounds. 1, 4, 2, 1, 3, 5, 6, 2, whatever. It keeps going. 2 decimal places are right here. When I'm looking to round to 2 decimal places, I look 1 past the 2. Is it 5 or greater? No. So it's going to be 14.1 what? 4. You leave it alone. Very good. So 14.14.
How did you get that? Like, where did the 1 4 plus 1 4 2
Okay, some number times itself gives me square root of 20, or 200. All right, so if I took this number and I multiplied it by itself, it's going to give me back to this number, 200. All right, the square root means I am taking half of a number, or I'm taking that number divided by itself. Yeah, half of that number. So a number times itself gives me 200. And when I typed it in my calculator, because I don't know it in my head, it was 14.14, and it keeps going forever. The square root of a number, guys, is an irrational number if it doesn't come out, so it keeps on going forever. So either you have to simplify the square root. Remember doing our little factor trees and making a number? You could do it that way. And if it tells you to round is the only time you do this. Okay. Do you remember simplifying a radical? We did it earlier this year. If not, make sure you ask. All right, in example 5, the distance formula, use the distance formula to find the given length. A rectangle with a length of 4 units and a width of 3 units. Find the diagonal, the length of the diagonal. Okay, guys, in your head, quickly, what could be an ordered pair if I have a rectangle and the length being 4 units? Where would you start?
0
0, 0. There's a coordinate for 0, 0. What's another coordinate?
0 4
0, 4. What's another coordinate?
4 0.
Not 4, 0, because we have,
3 4
it could be 3, 4. No,
3 0.
3, 0. Okay, so those are quickly coordinates that we would use. You could draw it up, that's fine. Now which ones would I use to find a diagonal?
0 4 would be a 0.
Yes, these would be a diagonal. Could there be other ones?
Yeah.
Or these? Okay, one of those sets you could use to find the diagonal. On a rectangle, the diagonals are congruent. They're the same, so you could use either one. All right, which one would you like to use?
0.
0, 4, 3, 0, that's fine. If you use the 0, 0, 3, 4, you'd save yourself just a little bit of trouble, but that's fine. We'll do that one. All right, so we're using 0, 4, and 3, 0. X value, 0. The other X value, 3. Square it. Plus the Y value that I did first, 4, minus the other Y value, 0, and square it. What's 0 minus 3? Negative 3. And a negative 3 squared has to be positive. Negative 3 squared is? 9. 4 minus 0 is 4. 4 squared is? 16. 9 plus 16? 25. And the square root of 25 is? 5. So it's 5, whatever units we're talking about. If it doesn't tell you, write the word units. If it does, write the correct units. Is that okay?
Yeah.
Any other questions? Okay, an isosceles right triangle with legs of 2 units. Find the length of the hypotenuse. Isosceles means they have congruent sides, right? If the legs are 2 units, that means they're the same. How do you find the length of the hypotenuse? Excuse me, I didn't make a right triangle. That would probably be easier to see. So if I made a right triangle, all right, and these units are the same, it's a 2 and a 2, how would you find the hypotenuse? What's the coordinates? 0, 2, and 2, 0. Now could you find the distance? Right. Distance equals your x value subtracted from each other plus the other, or the y value, subtracted from each other. So negative 2 squared is 4. 2 squared is 4. 4 plus 4 is 8. So I wanted to simplify the square root because it didn't tell me to round it. Factors of 8 are what? 2 and 4. 4 is a perfect square, but if you didn't see it, 2 and 2. Group them together. 2 times 2 is, so you get the square root of 4 times what's left over, the square root of 2. What's the square root of 4? So your answer would be 2 square roots of 2. That's the same as the square root of 8. That would be your answer. Okay. For your benefit, for later on, those of you that are taking the ACT pretty soon, you could have used a set of coordinates. And what would be quicker if you're dealing with a right triangle? This only works with a right triangle. You with me? Any type of right triangle, you can use Pythagorean theorem. A squared plus b squared equals c squared. C is always your hypotenuse. A and b are the legs of the right triangle. So 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. 8 equals c squared. All right, take the square root of both sides to get rid of a square. Square root of 8 equals c. And we said that if you simplify the square root, you get 2 square roots of 2. Okay, that is quicker, I think. Okay, because I can do that a lot quicker in my head. But that only works with a right triangle. Good? The distance formula works with anything. You can do it anytime you want.